it is very true that we don't know anything about the soda bottle or the steam locomotive just because we can poke at it. Again, we anthropomorphize, and that's actually gets us into trouble sometimes because I'm not feeling the quantum mechanics when I'm touching this.
That's right.
And therefore, it's easy to forget and feel like this is real and mathematical objects are not. But you're making the opposite argument. And you draw a distinction between numerals and numbers, which numerals are the representation of the number on the page and so on. But could you say that a number is real? Do numbers exist?
I happen to think so. I mean, I'm on the side of realism in mathematics, and I think that these abstract objects do have a real existence in a way that we can give an account of in a way I just tried to describe.
So, like you would describe it as a size of a set
Well, there's
with four
different
elements
ways
in
to
it.
understand the nature of four. I mean, actually, this gets into the question of structuralism, which is maybe a good place to talk about it.
What is structuralism?
Structuralism is a philosophical position in mathematics, or the philosophy of mathematics, by which one emphasizes that what's important about mathematical objects is not what they're made out of or what their substance or essence is, but rather how they function in a mathematical structure. And so what I call the structuralist attitude in mathematics is that we should only care about our mathematical structures up to isomorphism. If I have a mathematical structure of a certain kind and I make an exact copy of it using different individuals as to form the elements of that structure, then the isomorphic copy is just as good mathematically, and there's no important mathematical difference that would ever arise from working with this isomorphic copy instead of the original structure. And so, therefore, that's another way of saying that the substance of individuals, in a mathematical structure is irrelevant with regard to any mathematical property of that structure. And so to ask a question like, what is the number 4 really, is an anti-structuralist thing, because if you have a structure, say the natural numbers, with all the numbers in it, 0, 1, 2, 3, 4, and so on, then I could replace the number 4 with something else. Like, this bottle of water could play the role of the number 4 in that structure, and it would be isomorphic. And it wouldn't matter at all for any mathematical purpose to use this alternative mathematical system. That's to say that we don't care what the number 4 is really. That is irrelevant. The only thing that matters is, what are the properties of the number 4 in a given mathematical system, and recognizing that there are other isomorphic copies of that system, and the properties of that other system's number 4 are going to be identical to the properties of this system's number 4 with regard to any question that's important about the number 4. But those questions won't be about essence. So in a sense, structuralism, a kind of anti-essentialism in mathematics.
So is it fair to think of numbers as a kind of pointer to a deep underlying structure?
Yeah, I think so, because I guess part of the point of structuralism is that it doesn't make sense to consider mathematical objects or individuals in isolation. What's interesting and important about mathematical objects is how they interact with each other and how they behave in a system. And so maybe one wants to think about the structural role that the objects play, in a larger system, a larger structure. There's a famous question that Frege had asked, actually, when he was looking into the nature of numbers, because in his logicist program, right, he was trying to reduce all of mathematics to logic. And in that process, he was referring to the Cantor-Hume principle that, whenever two sets are equinumerous, then they have the same number of elements. I mean, if and only if. And he founded his theory of number on this principle. But he recognized that, there was something that dissatisfied him about that situation, which is that the Cantor-Hume principle does not seem to give you a criteria for which things are numbers. It only tells you a kind of identity criteria for when are two numbers equal to each other. Well, two numbers are equal just in case the sets of those sizes are equinumerous. So that's the criteria for number identity, but it's not a criteria for what is a number. And so this problem has become known as the Julius Caesar problem, because Frege said, we don't seem to have any way of telling from the Hume principle whether Julius Caesar is a number or not. So he's asking about the essence of number and whether, of course, one has the sense that he picked maybe what he was trying to present as a ridiculous example, because maybe you have the idea that, well, obviously Julius Caesar is not a number. And there's a lot of philosophical writing that seems to take that line also, that obviously the answer is that Julius Caesar is not a number. But the structuralists disagree with that position. The structuralist attitude is, look, you give me a number system. If Julius Caesar isn't a number, then I can just, let's take the number 17 out of that system and plug in Julius Caesar for that role. And now I've got a new number system, and now Julius Caesar happens to be the number 17. And that's totally fine. Yeah. So the point of structuralism is that the question of whether Julius Caesar a number or not is irrelevant to mathematics. It is irrelevant because it is not about structure. It's about this essence of the mathematical objects. So that's the structuralist criticism of Frege's point.